Okay, today we are going to look at volume of different 3D figures. So the first type that we're going to look at are called prisms. And a prism is a polyhedron, which a polyhedron is just a 3D shape with some flat sides with two opposite ends. Those opposite ends are going to be called bases. And those bases are parallel polygons. So like for example, in this triangular prism right here, your bases would be the two triangles that are opposite each other there. In a rectangle or a cube, your bases are either rectangles or squares. In this pentagonal prism, your bases would be the pentagons on each end, and so on and so forth. So, to find the volume of a prism, it's important to know what the base is, because the volume of a prism is the volume of the base, or the area of the base, times the height. So let's look at a little bit more with this. The base may be several different shapes. I put several here that are just common ones that we'll see. We might see some like a hexagon or a pentagon or something, but I don't think we're going to see that much. So triangle, rectangle, square, parallelogram, and trapezoid. All of these formulas are given here. Some of these you should be really familiar with, such as the triangle, which is area equals 1/2 base times height. Rectangle is just length times width. A square is the length of the side squared. A lot of times we'll use an S instead of an A there. They use the A here. A parallelogram is the base times the height. The base and the height must be perpendicular to each other. So that height is that vertical height, not this slanted height right here. Same thing in a triangle. Your base and your height must be perpendicular to each other. You wouldn't use a slanted side there. And then there's a trapezoid, which is going to be 1/2 times the sum of the first base and the second base multiplied by the height. Sometimes you might see this formula where they use a B1 and a B2 instead of an A and a B there. Whenever we're looking at prisms, the bases are the sides that are not rectangles. Unless you are looking at a rectangular prism. So right here it says except for in a rectangular prism, where all sides are rectangles. So, over here I have several different figures. Some are prisms and some are not. So for example, one that is often difficult to think of as a prism is E right here. E is a triangular prism. And you can see you've got these two parallel triangles here that are connected by rectangles. Okay, so there are rectangles in this shape, but they are what we call the lateral sides. They are not the bases for this. So E would be a prism. This is often confused with something like A. A is not a prism. It doesn't have any rectangles, and this would be called a pyramid, which we're going to look at more here coming up. So that would not be a prism. F down here is also another type of pyramid. This is a pyramid with a hexagonal base here. So those two are not prisms. B right here, everything is rectangles. The ends right here look like they're probably squares, but we don't know that for sure, and all the sides are rectangles. This would be called a rectangular prism, which is just a box there. And D is also a prism. The bases for these are the sides that are not rectangles. So that's this here on the front, and then that same shape there also on the back. And that shape is a trapezoid. So this is called a trapezoidal prism. So that is also a prism. It's really important to be able to know these things because if you don't, you won't know which formula to use to find the volume of these. If you have a pyramid and you're trying to use a prism formula, then you're not going to get the answer right. So let's look at these two examples here. For the first example, we just have a very straightforward rectangular prism. So you actually probably have known how to do this for a really long time. The volume formula is the area of the base times the height. Well, for this particular shape, your base is a rectangle. It really doesn't matter which rectangle you use as your base. I like to use the one on the bottom, but the base is not always necessarily on the bottom here. And to find the area of that base, it's just your length times your width. And then we're going to multiply by the height. So a lot of times whenever you do this formula, rather than thinking base times height, you do length times width times height, which is also true. And for this, that length would be 7. The width right here would be 5. And then the height of the prism is 3. There. And so if we multiply those together, we got 7 times 3 times 5, which is going to give us 105. We do want to put units with all of our answers. And when we multiply centimeters times centimeters times centimeters, we get centimeters cubed. Whenever you're doing volume, your units should be cubic units because you have 3 different dimensions that you are multiplying together. That's why we call these 3D figures. For example 2, here we have a triangular prism. So our bases are these triangles here. They're this one on the bottom, then the one on top as well. So if we're doing volume is area of the base times height for this one, then the volume would be the area of the base, which is, this is a triangle, so that's 1/2 little b base times height, and I'm going to put an H1 right here because that's the height of the base, and I'm going to multiply that by the height of the prism, which is 2. So I'm going to separate those two because I don't want to use the same letter for them there. So in this case, in this triangle here, the base of that triangle would be this side here, which is not labeled on this particular picture, but the length of this side should be the length of this top side as well. So we know that that base right there is 5, and then the height of that triangle is going to be perpendicular to that base, and that would be 1.5. And then we would need to multiply this by the height of the prism, which is the height, the length of the side that connects these two right here. So that would be 4 over here. So we can just type that into our calculator real quickly. We've got 1/2 times 5 times 1.5 times 4, and that is going to give us 15. And these are yards, and that should be cubed because we're talking about volume there. So, moving on. A cylinder is basically the same as a prism when we're talking about the volume. A cylinder is a 3-dimensional shape consisting of 2 parallel circular bases joined by a curved surface. If we look at the volume, it's pi r squared times height. But if you look at this part of the formula, pi r squared, that's the area of a circle. So it's really still the area of the base times the height for these that we're looking at. So for this particular one that we're looking at, we've got a cylinder, and we would say that the volume is pi times the radius, which is 8 squared times the height, which is 15. So if we type that into our calculator, we will get pi 8 squared times 15. It's going to give us, you'll see this written a couple ways a lot of times. They may not multiply the pi in there. They may just do 8 squared times 15. So they might write it like this, 960 pi centimeters cubed. Or they may go ahead and give you the full decimal there, which will be 3015.93 cubic centimeters. So you could see either one of those as the answer. If it has the pi right here, they just haven't multiplied that pi back in. All right. Now, if we were in class, I would do this actual experiment. But I would like for you to think for a second how many cones of water it would take to fill up a cylinder that has the same base and the same height. So you can see we got a cylinder here and a cone, and the size of the bases of both of these are the same, and the height of both of these are the same. So what I want to know is if I took this cone right here, I turned it upside down, and I filled it up with water, and I poured it into this cylinder, how many times do you think I would have to do that before I would fill up the cylinder? You think it would take 2, 2.5, 7? What do you think? So I want you to take a guess real quick. If we were in class, I would actually do that. But instead, I have a video demonstration here where someone has done it. They kind of give it away here at the beginning. So we want to know, is a cone a third the size of a cylinder? It's kind of giving it away there. So I'm going to fill this up once, twice, and a third time there. So the answer to that question, how many cones of water will it take to fill up a cylinder that has the same base and height? That would be 3. To me, it doesn't quite seem like it should be 3, but it is 3. There. So whenever we look at the formula for a cone, we're going to see that shown. A cone is just a third of a cylinder. So its volume equals 1/3 pi r squared times height. A cone is a three-dimensional shape that narrows smoothly from a flat circular base or to a point called, this point on your cone, this point on your cone right here is either called the apex or sometimes the vertex. So a cone should have, a pointy part right there called the apex that will help us identify it. So if we want to find volume here, we're going to do 1/3 pi times the radius of the base. That radius of the base for this one is 5 squared. And then the height. Now on this cone, you got a couple of heights you've got to choose from. Whenever we're talking about the height that we need for volume, we need the vertical height. This over here is called the slant height. And if you're doing surface area, you need that. But we do not have to do surface area. We are just looking at volume. So right now, volume, we use that vertical height, which is 12. So if we type that in, 1/3 times pi times 5 squared times 12 is going to give us 314.159, and that would be cubic inches. Okay. Pyramids are going to be very similar to cones. Pyramids, much like the cone, are going to have this 1/3 right here. So if we have a pyramid and a prism that they have the same base and the same height, then it would take 3 of those pyramids to fill up the the prism as well. So our formula is 1/3 area of the base times height. So for this particular pyramid, right here is our apex or our vertex, the top of that pyramid. And we've got these 3 triangles on the side that are our lateral sides. And this pyramid down here on the bottom is our base. So our volume is area of the base times height, which for this, our base is a triangle. So we have to do 1/2 base times, I'm going to call that H1 and this one H2 for that. So if we're looking at the bottom here, which is our base, then our base and our height of that triangle have to be perpendicular to each other. So the base of that triangle right there is 13. So we got 1/2 times 13 times the height has to be this perpendicular height here, which is 15. And then we need to multiply by this vertical height of the pyramid, which would be 18. So if we type that in, we've got 1/2 times 13 times 15 multiplied by 18, and we're going to get 1,755, and that would be meters cubed for our answer there. All right, we have one more type of solid that we need to know how to find the volume of, and that is a sphere, which is just a ball. It is a round solid figure or its surface with every point on its surface equidistant from its center. So whenever you have a sphere, all the points on the surface of the sphere are the same distance from the center. The volume of a sphere is 4/3 pi r cubed. Make sure you're using a cube right there because the other problems all have squares in them, so it's easy to get that mixed up. So we have a word problem over here for this one. It says the radius of the moon is approximately 1,738 kilometers, and the radius of the earth is approximately 6,378. That should have been changed to kilometers. I didn't change it whenever I changed that. That should be kilometers. So it asks us, fill in the blank. The volume of the earth is blank times larger than the volume of the moon. So in order to answer that, we have to find the volume of the earth and the volume of the moon. So we would do, for the moon, we would do 4/3 pi times 1738 cubed. And we are going to get a big number, I'm sure, here. So 4/3 pi 1738 to the 3rd power. And when we do that, I'm getting 2.1996 E10, which means that's what's showing up on my calculator. That means this decimal needs to be moved 10 places. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fill those in with zeros. We'll have 2199061, 2, 3, 4, 5 zeros right there. So we're looking at 21 billion, and this is kilometers cubed. For the Earth, it's going to be even larger. We'll have 4/3 pi, and we'll have 6378 cubed. So 4/3 pi times 6378. Oops, I'll type that in. 6378 to the 3rd power. And that is going to give us 1.08678 E12. And so that would be, we'd have to move that decimal 12 places, so we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So okay, so if I want to know how many times larger this is, I would need to take my larger number and divide it by my smaller number. So if I do that in the calculator, I should get 49.4202. So I'm going to put this little symbol right here, which means approximately 49 times. So about 49 times, 49 to 50 times larger than the moon. Notice, if you do 6,378 divided by 1,738, you are going to get 3.66. So you can't just divide the radius of each. You have to find the volume, because once you find the volume, it's going to change by a magnitude of 49 there instead of just 3. All right, so let's keep going. I've got a few word problems that we're going to look at here. For 7, candle A has a diameter of 4 inches and a height of 8 inches. Candle B has a diameter of 6 inches and a height of 5 inches. Which candle contains more wax? So if we look at candle A, we have a diameter of 4 inches, and then we have a height of 8 inches. Now, our formula for this is pi r squared times height. It calls for the radius, not the diameter. So be careful with this. If your diameter is 4, your radius is 2. So you would do pi times 2 squared times 8. I like to do this and just leave the pi there. So 2 squared times 8 is 32. So we could call this 32 pi, or if you want to do the decimal, 32 times pi is 100.531. Over here, for our other one, we would have a diameter of 6. So we've got a wider candle, but we only have a height of 5. So we have a diameter of 6 and a height of 5. So we would need to do, and this is inches, cubic inches there, we would need to do pi times radius here is going to be 3 squared times the height of 5, and that is going to give us 45 pi if we just do, leaving the pi there, or if we do 45 times pi, we will get 141.372 cubic inches. So candle B has more wax. Okay. Number 8 is an interesting question. One guppy requires about 5 liters of water to live happily. What is the maximum number of guppies that should be kept in this aquarium? So we have an aquarium and its dimensions. The volume of this is very simple to find. You're just going to do 30 times 40 times 30 here, and 30 times 40 times 30 is going to be 36,000 cubic centimeters here. That is our volume. However, we don't know how many cubic centimeters a guppy needs. We know how many liters of water it needs. But it does tell us that 1 liter of water is 1,000 cubic centimeters. So a guppy, one guppy needs 5,000 cubic centimeters. So if we take 36,000 and divide it by the 5,000 cubic centimeters needed by every guppy, we are going to get 7.2. Of course, we can't have a 0.2 of a guppy, so we would say 7 guppies. There. Moving on. For example 9, we're asked to find the diameter to the nearest unit of a cone with an approximate volume of 22 cubic feet and a height of 21. So, let's draw ourselves a picture here. We've got a cone, and we've got a height of 21 feet. We do not, it asks for the diameter, but really if we could just find the radius here, then we could just double that to get the diameter. But we don't know what the radius is. We do know the volume, so you're going to have to kind of work backwards on this. Our volume formula for a cone is 1/3 pi r squared times height. So if we plug in the things that we know that volume is 22, the 1/3 and pi are just both numbers that don't change. We do not know the radius, so we have to leave it as a r squared. But we do know the height, which is 21 feet. So these parts right here, 1/3, pi, and 21, those are all numbers that we could multiply together. So if we do that, we can use our calculator. 1/3 times pi times 21 should give us, I'm going to go ahead and use the decimal for this. Oh, blue. 22 is going to equal 21.9911, and then we still have that radius squared. So if we're solving this, we need to divide by that 21.9911. And so if we divide there, we get 1.0004 equals the radius squared. And then to get rid of that square, we just take the square root. If we take the square root of that number, we are going to get 1.0002 for our radius. The question did not ask us about radius. It asked about diameter. So to get the diameter, we need to double this, so we'll get 2.0004, and that is in feet there. Okay. Number 10 is another one where we have to work backwards. We have a sphere, and we know the volume and are asked for the radius. So our volume formula is 4/3 pi r cubed for a sphere. And we know the volume. The volume is 342, and that's 4/3 pi r cubed. So what we can do here is we can go ahead and multiply 4/3 and pi together in our calculator. It is going to give us, if we do a decimal, it is going to give us 4.18879. And then we still have that radius cubed. We need to divide both sides by that number. So if we divide both sides by that number, we will get 81.6465 is equal to our radius cubed. And then we will need to, instead of doing a square root here, because this is a cube, we need to cube root this. And actually, let me show you how to do that on Desmos, because I need to know where that is at. We may have already talked about it, but for Desmos, if you click right down here, go to Functions, scroll down towards the bottom. Well, I thought it was towards the bottom. Maybe it's not that far towards the bottom. Where's it at? Oh, you can't see it for the, hold on. Can't see it for that. It's right here at the bottom. This en route, we're going to do that, and it'll let you put a 3 right here. And then you can just type in that number, 81.6465, and we get 4.338 as our answer. So let's make that go back where we can see it. So our radius is 4.338, and that would be inches there. All right, just a couple more that we need to look at. For 11, it tells us a rectangular prism has a length of x, a width of 2x plus 1 centimeters, and a height of 10 centimeters. Write an expression that can be used to find the volume of the rectangular prism. So a rectangular prism is just a box. Here. And in this box, we have a length of x, a width of 2x plus 1, and a height of 10. So if we want to know the volume, you're not going to get a number answer for this. We would do x times 2x plus 1 times 10. And probably they would either write it like this, 10x times 2x plus 1, or they may go ahead and distribute that 10x and call it, 20x squared plus 10x. So either this or this would probably be the answer that you would see for that. And then the value of x could change. If x was 5, then this side would change. If x was 10, this side would change, and that would change your volume as well. Our last problem here, we have a cube-shaped bead. It has side lengths measuring 12 millimeters. Each bead has a circular hole in the middle. The diameter of the circular hole is 2 millimeters. Find the volume of the bead. So for this, we're starting with a cube, and each side of this cubic bead is 12. So this side is 12, this side is 12, this side right here is 12. So volume of that is very easy to find. We just do 12 times 12 times 12, or 12 cubed. And if we do 12 cubed in our calculator, we get 1728 millimeters. But there is a hole going down through this bead. So the diameter of that is 2 millimeters, which means the radius is just 1. So the volume, this is going to be a cylindrical hole. So we're going to have pi r squared times the height, and the radius is just going to be 1. And the height would be 12 because it's going to be the same height as the bead. And so if we type that into our calculator, we will get 37.6991 millimeters. I should put a cube on that right there. So to find the volume of this bead, we would need to subtract these two because that hole is cut out of the bead. So we would do 1728 minus 37.6991. And that would give us 1690 point, I'm just going to round that to a 3 right there. And that is cubic millimeters for that. So that would be our answer for this last problem. You are going to have a Desmos classroom that you are going to do to practice this a little bit more. So work on that in class, and we'll talk about any questions that you have on Monday.